Let's lessons in prayer. Father Lord, we want to say thank you so much for this day. We thank you for this new month. We thank you, King of all kings, for thus far you have brought us. We thank you for this lesson. We ask that you come and teach us, the Holy Spirit, and that we'll be able to remember each and every concept, O Lord, and be able to apply it whenever asked or whenever question or scenario is set, O Lord. King of all kings, continue to strengthen each one of us, Lord, to pursue that which is our goal, King of all kings, and we continue to bless our teacher who puts in his time and his efforts for us. Lord, we give you all the praise in Jesus' name. Amen.
Amen. Thank you so much, Ruth, for the word of prayer. And good morning, everyone. Thank you so much for joining in. So today we are going to look at some of the applications of exponential and then the logarithmic functions. Now, some of the applications for this particular topic, we can find applications in areas such as in population growth. You can find, like, when you look at the curves, let me say you are looking at population growth, you'll find that the curve is somehow like this. That is for the population growth. You can find it in applications such as in economic growth. That is in economics. Economics, you can find it in population growth. You can find it in economic growth. You can find it in money valuing. You can find it in things of inflation. Yes, such things. Then in science, you can find this particular topic in areas such as in the radioactive decay. When you look at that area, you can find it in that area of radioactive decays. But then also, you can find this particular topic in physics when you want to model things concerning the movement of the planes. You can also find this particular topic. However, we are going to first look at where can we apply it in differentiation. Under which circumstances can we be able to apply using the natural log and using the exponential. Like when you meet a given differential equation, like an equation, where can you apply it? So we are going to look at those kind of things, and then from there, we shall be able to build it on. So we shall look at scenarios at a later time, but now we are going to first look at if you have met a differentiation number, can you be able to apply it? Because like last time I told you that this particular topic can be uh, used to simplify your life. You can use it to simplify your life when you meet a differentiation number. So we are going to look at the first one, differentiate with respect to x. And what is the first number we are going to look at? We shall have our first number, y is equal to x cubed divided by the root of 1 minus 2x squared. Now, I know that when you look at this number, one of the approaches we can utilize is the approach of the quotient rule. Yes, it is very well. But in case you don't want to use the quotient rule, which other rule can you use? Now, the other rule that I want us to use is going to be introducing of the natural logarithms, because I told you it can work everywhere. And sometimes you'll find that it is much easier using the natural log. So we say that the moment you notice that this is differentiation, you can introduce your natural log on both sides. So we can say that natural log of y is equal to the natural log of x cubed out of the root of 1 minus 2x squared. But like I told you that natural log is the same thing like having your logarithms. And for your logarithms, we can break this into further into natural log of x cubed minus the natural log of root of 1 minus 2x squared. Because you know that in logarithms, when you have a division, is the same as a subtraction. Now, the moment you reach here, you can simplify it further a bit by saying that this is natural log equals to natural log of x cubed minus. Now, when you look at this, I can write that as 1 minus 2x squared everything power a half, which even you can further go and write as natural log of ln of x cubed minus. You can drop the power and say this is a half the natural log of 1 minus 2x squared. Now, the moment you reach here, you go back and differentiate. Remember, we said that when I have a natural log of any function, or let me say x, what I do, I differentiate what I have here, and then after I divide by what I differentiated. So here we shall have 1 out of y with respect to dy is equal to, when we differentiate this, we shall end up with 3x squared, everything divided by x cubed, minus, this is going to be a half. Then I differentiate what I have inside. This one is going to give us the negative of 4x divided by 1 minus 2x squared. Now, the moment you reach here, we can go on and simplify. But remember, everything this side, we have differentiated with respect to dx. So here it shall have 1 out of y dy is equal to, these are 2, these are 3. So I remain with 3 out of x minus by 2, 1 by 2, 2. So I remain with, this is a minus and a minus, which gives us a plus 2 of x divided by 1 minus 2x squared, then everything with respect to the x. Now, what are we going to do? We can now remove our dx. We are going to remove this dx by dividing by the x, dividing this side by the x. But also you notice that there is a y, so we are going also to multiply through by y this side, such that it can as well go the other side. But if you want, you can as well first simplify this alone, and then you know that there my LCM is going to be x into 1 minus 2x squared. Then you say the whole of this divided by this, you end up with 3 into 1 minus 2x squared, then plus 2x times the x. So when you simplify, you'll have 3 minus the 6x squared plus the 2x squared divided by x into 1 minus 2x squared. Now, negative 6 plus 2 will give us a negative 4. So you end up with 3 minus 4x squared out of x into 1 minus 2x squared. So what I'm going to do, I'll come here and I say now, this is 1 out of y. dy is equal to 3 minus 4x squared divided by the our x into 1 minus 2x squared. Then everything, it is still multiplied by the x. So when we remove this y, we remain with dy dx equaling to 3 minus 4x squared out of x into 1 minus 2x squared. Then I multiply by my y. But to get my y, I come back here because we had our y. So I'm going to come here and then I say my dy dx will equal to 3 minus 4x squared out of x into 1 minus 2x squared times y, which is x cubed out of the root of 1 minus 2x squared. Now, this is your answer. But when you look at this answer, it's not simplified. So you can say here you can reduce by x1. Here we remain with x squared. But when you look at this denominator and you look at this, these two can be simplified further because you have 1 minus 2x squared. This one is like to power 1. And you have 1 minus 2x squared, and this is to power a half. Now, these two numbers have the same bases, meaning you can add the powers. So that means you can say 1 minus 2x squared, then 1 plus a half, which will give us 1 minus 2x squared. This is going to be 3 out of 2. So that means that your denominator is going to remain with this. Then in your numerator, you still have this x squared that can multiply here and can multiply there at the same time. Or if you want, you can leave it outside. So now I'm going to just come here and I say that now my answer can be in simplified form as 3 minus 4x squared. This is x squared divided by 1 minus 2x squared, everything 3 out of 2. Now, in case you want, you can still write this denominator of ours. If you want, you can still write it in this form, like they gave it to you in form of a root. You can as well go on and say, but me, I want to write it in a root form. So you can say for x squared, you have your x squared here out of, now it will be root of 1 minus 2x squared, everything cubed. So you can write it in that format. Members, are we still on the same page or there is a question? If you have a question, you may ask, or in case you are getting there's something that's not clear, you may ask. Are we on the same page? No, not yet. Okay. Uh, yes, Ruth?
Someone asking for help on letter half on the fourth step. Yeah, fourth step.
Fourth step.
Like, okay,
One,
the
two, three.
principle, like
Here.
wrote letter half this side. Yes.
Uh-huh. Okay, Ruth, you know that in logarithms, if I have a power b, I can write this as b log of a.
Okay.
Remember
So
that
then,
principle?
yes, it I remembered.
Mm-hmm.
Then, this side on this step now, on this other side of the first step on the other side of the what? Of the red line.
Here.
Yes.
Mm.
So from how did we come from here to this side? Was it
Oh,
LCM?
yes, yes. Like we simplified. When you look at this, your LCM, I don't know which method you use. Do you use this one of just cross multiplying?
No, no. I use
You
LCM.
use
I divide
LCM.
then multiply.
Uh-huh. So your LCM was this, right? Of the
Let
two.
me.
True? Or you are still finding out truth?
Okay, as long as you've told me it's LCM, I'll see. Too.
Okay, yeah. So this is the LCM. And then when you get this divided by this, then you end up with 3 into 1 minus 2x squared, then plus
Oh,
2x
okay, teacher.
times
Then that
x.
means that's on the screen is what? Just the same on the screen.
Hey, this is just a summary. Okay, okay. Other people, are we on the same page? Dr. Jimmy,
Good morning, sir.
morning.
Master, I once said that if we have ln
Mm,
of a number inside, we can make it enter. For example, there in step, let me see, step 3.
mm.
Why didn't we make the ln to enter? We make ln 1 minus ln 2x squared.
We're here.
Yes.
Oh, like if you want, you can break it further. That's when you want to break it further. It is okay.
But will we get the same answer also?
Yes, you get the same answer, but now here, remember, when you look at, you need now to remember the laws that if now you have something like this, now it means that when you're breaking it, it instead becomes ln A out of B.
Okay. Okay.
Eh, of which now
Thank
you
you.
are complicating it further now to differentiate.
Okay. Thank you.
Mm, okay. Mm. Sammy?
Good morning, sir.
Yes, morning.
So I'm still on that third step, yeah.
Mm,
So on ln x cubed or power 3, but
mm.
if we drop the power 3, how do we deal with that?
It is okay. If at all you wanted, Sammy, that is very okay. You can say 3 ln of what? X. Then now you remember when you are differentiating, you differentiate this, you say 3 times. When you differentiate x, what do you get, Sammy?
I get 1 over x.
1 out of x. So your answer will be 3 out of x, which is the same thing we have here.
Okay, sir. Thank you.
Mm, okay. Okay. Members, are we good to continue? Cedric, I don't know where you're getting the problem. Maybe you can ask Cedric. Okay. 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 So we are going to continue. We are going to continue and look at another example. So today, whatever thing we are doing, we are going to just apply the lines, the lines or the exponentials. And always, for you, what you have, sometimes it is an easier way to do. Much as for this number, it is okay, members. You can use your U, you can use your V. It is still very, very okay. So we look at another one. Now the second one we are going to look at, it is here. It is here because sometimes it depends on which kind of thing has been given to you. Yes, it depends on what has been given to you. Okay, we have another one here. Given that y is equal to 1 plus the sine of x out of 1 minus the sine of x. Show that your dy dx is the same as 1 out of 1 minus the sine of x. That's what we are going to deal with. Now, when you look at this number and you are approaching it, look at it very well and ask yourself, what can I apply? So when you look at it, we are going to do step by step until we get there. So I can write this number as y is equal to 1 plus sine of x out of 1 minus sine of x. But since there is a root, I can first decompose it into power a half, like that. Now, before I come in with my lane, I can first separate it. It is very okay. If you do not want to separate it, what do you do? What you do is you make sure you have to remember that this half affects the numerator and the denominator. So I can introduce in my lane. So I can say lane of y is equal to the lane of everything 1 plus sine of x divide by 1 minus sine of x, but everything to power a half. Now, the moment you reach that point, like I told that ln is the same as the natural log, but to base e. So you know very well that if I have from your logarithms, I have log of, let me say, base a, and this is maybe c power m. This m can come here, and this is the same as m log of a to power c. Now this half here, we can make it come this side, such that our thing becomes a bit much easier for us to differentiate. So now I can continue and say this is the natural log of y is equal to a half natural log of 1 plus sine of x divided by 1 minus sine of x. Now, at this point, since there is a division, still you go back that the natural log of a minus the natural log of b is the same as natural log of a out of b. Now, this is what you have, but we can write it in this format such that our thing becomes much easier to differentiate. So I'm going to come here and I say this is the natural log of y is equal to a half. But this a half multiplies everything. So I will put these kind of brackets and I say now this is the natural log of 1 plus the sine of x minus the natural log of 1 minus sine of x. Members, first let me know whether we are on the same page up to that point. In case you are confused, there's anything that's not clear up to that point, you can let us know such that we can move. Okay, people are saying same page. Okay, together. Yes, So, can we differentiate from here? Can I first request you now to first differentiate go before I do differentiate it here? First differentiate and see whether we can be on the same page. Remember, if you want, even at this point, if you want, you can first bring this circle half inside. There is no problem. So we are going to differentiate. Start with differentiating the y. When you differentiate y, you get 1. So here we shall remain with 1 out of y, but with respect to the y, equals to 1 out of 2, these brackets of ours, 1 plus sine x. When you differentiate 1, you get 0. When you differentiate sine, you get cos. So that means we shall have cos x out of 1 plus sine of x minus, when I differentiate now, the sine x, I get cos, but there's this negative, so I get negative cos of x divided by 1 minus the sine of x. Do not forget that there is a negative here. So this negative, then times the cos. So that is the negative here. So now that means I will combine these two to get a plus. So we shall continue, but everything we have differentiated with respect to x. So now I'll have 1 out of y with respect to the y is equal to 1 out of 2 into cos x plus cos of x. But here I'll have 1 plus sine of x. Then this side I have 1 minus sine of x. Don't be tempted to add the cos plus the cos, not yet. So don't be tempted to add the two. So I can first remove this dx by bringing it this side. So I'll get 1 out of y dy dx equaling to 1 out of 2 into. Now what I have inside the bracket, I can first reduce it. Or I can first say that what is my LCM of 1 plus sine x, 1 minus sine x. Members, that is the same as 1 plus sine of x into 1 minus sine of x. Now, first avoid bringing in the difference of two squares, because at this point, I do understand that you can bring in the difference of two squares, but better you first simplify. So when you divide, we shall have here cos of x into 1 minus sine of x plus cos of x into 1 plus sine of x. Now you continue and do your multiplication. So when cos enters, I'll have cos of x minus sine x cos of x plus the cos of x plus cos x sine of x. Then if you want, you can now multiply the denominators. So when you look at the denominators, I can say that is the same as 1 minus sine squared x. Hope everyone is, I don't know that we are seeing that. When you have 1 plus sine of x and you have 1 minus sine of x, the moment you open the brackets, you have this one multiplying everything, 1 into 1 minus sine of x, then this sine x multiplying everything, which is plus sine of x into 1 minus sine of x. So when you open, you have 1 minus sine of x plus sine of x minus sine squared of x. So these two will cancel and you remain with 1 minus sine squared x. So that's where we are getting it. So you can then simplify. You notice that this and this can go. So you remain with cos x plus cos of x, which is going to give us a 2. So that means I'll have 1 a half, then times 2 cos of x out of 1 minus sine squared of x. But this side, we still have our y, so do not forget that y. Now, at this point, we can now, these two and these ones can cancel. So once it cancels, it means that now I have 1 out of y dy dx equaling to cos of x into 1 minus the sine squared of x. Now, if you want, you can still go on and simplify. Allow me to go to the next screen. So the next screen, we shall have 1 out of y dy dx equaling to cos of x into 1 minus sine squared of x. Now at this point, you apply the rules again. You ask yourself from the first rule that sine squared x plus cos squared x is always equal to 1. Now, since I have 1 minus sine squared x, it means that cos squared x is equal to 1 minus sine squared of x. So where there is 1 minus sine squared x, we can put cos squared x. So I will say 1 out of y dy dx will equal to cos of x divided by cos squared x, which you can now go on and say 1 out of y dy dx will equal to, now cos x out of cos squared x is the same as 1 out of cos of x. Since we want dy dx, we remove our y. So we shall say that dy dx will equal to the 1 out of cos of x, but of y. Then we go back and we pick our y, because we know that, but our y, what was it equaling to? Our y was the square root of 1 plus sine of x into 1 minus the sine of x. Allow me to first pause and I ask whether we are still on the same page. Oh, same page? Are we still on the same page up to that point? Okay, people are saying we are still on the same page. Okay, now we are going to do something at this point here. We have y out of the cos of x. So what are we going to do? So now here, this is where you need to apply to have your mathematical eye. So here we are going to do something. Because we have times y, we can go on and rationalize. So we are going to do some rationalizing in order for us to remove the roots. So we shall come and say dy dx will equal to 1 out of cos of x, then times our y, which is going to be 1 plus sine of x into 1 minus sine of x. Now, at this point is where we can rationalize. So when we are rationalizing, you remember from your math, when you are looking at sides, that 1 plus sine of x into 1 minus sine of x. So here I can decide to multiply times 1 plus sine of x divided by 1 plus sine of x. I can do like that. So what is going to happen? So that is 1. But now, have a mathematical eye. You ask yourself, if I multiply this times this and this times this, remember at the end, always look at where you are heading. Where are we heading? Where we are heading, we must have 1 out of 1 minus sine of x. So you notice that once you do like this, you are not going to reach the other side because you are going to have 1 plus sine of x. This is going to be a bit more squared. Then here, you are going to have something. So you may notice that this one is not leading us somewhere. Let me just continue to show you. You will notice that you are going to have 1 plus sine of x, everything squared. Divide by, here down, you are going to have 1 minus sine squared of x. So when you try to continue a bit, you notice that up, you remain with 1 plus sine of x. Then down, you are going to have 1 minus sine squared x, which is cos squared x. And when you get the root, you remain with cos x. So you note that you have 1 plus sine x out of 1 plus. Okay, okay. So you notice that you're going to have 1 plus sine of x divided by cos of x. Is that okay? Not yet, because I'm going to apply two things now. Are we still together here, or I go slow a bit? I want to know whether members we are still on the same page for this. It is okay. Okay. Let me first pick Cedric. Yes, Cedric.
Oma teacher, you go slow, eh?
Okay. Let me first repeat here from this point. So here, I'm going to have 1 out of cos of x into, so here you have 1 plus sine of x into 1 minus sine of x. Now I can rationalize, though I will show you the second approach that could be a bit even much easier. So if you rationalize, you'll get 1 plus sine of x out of 1 plus sine of x. So what shall we have? We shall have 1 out of cos of x. Then what are we going to have up? Now up, we shall remain with root of 1 plus sine of x, but squared. Then down, 1 minus sine x, 1 minus sine of x into 1 plus sine of x. Now you can continue. Here, 1 minus sine x, 1 plus sine x, members know it very well that is the same as, so I can come here and say this is 1 plus sine of x, everything squared, divide by 1 minus sine, 1 plus that is 1 minus sine squared of x. Now I can continue and say this is the same as 1 out of cos of x into, I can now have my roots separated. Yes, I can say this is the same as root of 1 plus sine of x, everything squared, divide by 1 minus sine squared x is the same as cos squared of x. So here we shall remain with 1 out of cos of x into 1 plus sine of x. When you get the root, divide by the cos of x. So at this point now, you are going to ask yourself, what is cos x cos x? So this is going to be dy dx will equal to 1 plus sine of x into cos of squared x. Now, once you reach there, then you go back again. You ask yourself, but what is cos squared x? That this is dy dx is equal to 1 plus sine of x divide by cos squared, which is the same as 1 minus sine squared x. Then you come back again. That what is 1 minus sine squared x? So this is 1 plus sine x out of 1 minus squared is the same as 1 minus sine x into 1 plus sine of x. So 1 and the other one can cancel. So you remain with 1 out of 1 minus sine x. So that is your dy dx as the question wanted. Then another person, if you didn't want to go through this and you reach this point, another person could just multiply up here by 1 minus sine x divided by 1 minus sine of x. That is the second approach that I felt maybe it was a bit easier. Now, the moment you reach at that point, for someone who considers that, you'll have 1 out of cos of x. Then up there, you're going to have 1 plus sine x, 1 minus sine x. So that is 1 plus sine of x into 1 minus sine of x. Then down, you're going to have 1 minus sine of x, but everything squared. So you notice very well that up there, 1 plus sine x, 1 minus sine x is the same as 1 minus sine squared x. Divide by 1 minus sine of x, everything squared. Now, 1 minus sine squared x is the same as our cos squared x. Cos squared x out of, also I take the root down, 1 minus sine x, everything squared. So when you look at root of cos squared x is the same as cos x divided by this cos x which is down out of 1 minus sine of x. So the cos's cancel and you remain with 1 out of 1 minus sine of x. So someone could just do like this, or you could go through the other approach. But all the approaches, they will lead you to the same answer. So for you, look out which one can be a bit much easier for you. How is 1 plus sine x different? Yes, now 1 plus sine of x, everything squared. This is the same as 1 plus 2 sine x plus sine squared of x. But when I have 1 minus sine squared x, then this is the same as cos squared x. From the identity of sine squared x plus cos squared x is equal to 1. Okay, hope it is different. Hope you have seen the difference. So that is the difference. Okay. Okay. In case you have a question, there's any part that you have not obtained very well, kindly raise up your hand. In case there is any area you feel we need to go through, let me know. Yes, Cedric?
Teacher, is it possible you go back to the first page?
Or to the first page? Yes,
Yes,
okay.
like for 3 minutes, then you come back this side.
3 minutes. Could you, I don't know what you're using, but let me be taking back as you take a screenshot or copy. Yes, Moses. Oh, Moses? Okay. Yeah. Yes, Moses?
Good morning, sir. Teacher, I'm sorry for the delay.
Okay, yes, Moses.
Teacher, on this point, on the second last, the page you have just removed, on the second last method. So I'm asking myself, do I dx, this is the step, do I dx equals to 1 plus sin x? Have you seen there?
Divide 1 plus sine x here?
Yes. So what if I just write 1 plus sin x minus cos squared x? Can I have any progress with this?
1 plus sine x,
Minus, you don't
minus,
divide.
okay,
Minus
minus.
cos squared x.
You are asking whether?
Whether this looks to be the same according to me. Can I proceed with this?
Like 1 plus sine x minus
Yes.
cos squared x. Like you are
Yes.
saying it is the same thing like 1 plus sine x. Is it what you are
Out of
saying?
cos squared x. Out of cos squared x.
This one, everything out of cos squared
No,
x.
this one. This second one. Yes.
Oh, now they are
Mm,
different.
okay.
Because I don't know why you are putting a minus here. Could you have a reason why you are putting a minus? Or
Yeah,
where you
because of this division.
division? This one. Now
Yes. Mm,
okay, I'm seeing what you are trying to bring. Now we bring
okay.
in that kind of identity when you have a natural log. But here there is no natural log. So you cannot
Okay.
subtract them.
Okay.
Eh,
Thank you so much, sir.
okay. Baswali?
Good morning,
Yes,
teacher.
morning.
Now, on this second approach you were showing us, I was just confused on how you were multiplying with 1 minus sin x all over 1 minus sin x.
Okay. Now, Baswali, would you agree if I have one out of two, when I multiply it times 2 out of 2, is this fine?
Yes, I agree, teacher.
You agree that the answer is 2 out of 4, right?
Yes.
Now, the instance of things of rationalizing, is that you want to eliminate something. But as long as the mathematics you are applying that 1 minus sine of x, if I multiply up here by 1 minus sine x and down by 1 minus sine x, have I changed anything on the original thing?
No, teacher, because they cancel.
Because they do cancel. Now, if you can see it a bit early, that you can, instead of adding, you can subtract, then you can go up with that.
Okay, teacher, thank you.
As long as the mathematical thing remains the same. Even if here, because there are some numbers that you are going to reach on, maybe when they are for proving, whereby you need even to create something. I think we shall look at a number of that nature, whereby you have to create something, like you have to create a 2 there. You say 2 out of 2, then I bring in maybe cos squared theta. So you have to create something in order for you to get somewhere, or even to bring in an identity. Okay, keep sang. Keep sang. Oh, I'm failing. Oh, keep sang. I'm failing to get you. Okay. So let me just take back to the first screen such that people can just take a screenshot. Members, you can take a screenshot of that. As Rose asks. Yes, Rose?
Excuse me, teacher.
Hmm.
I joined a bit late. I wanted to know the topic for today.
Hey, we are looking at the application of the natural logarithms and the exponential functions.
Okay.
Okay, so I think people have finished. I've also finished to take there. So I think we can look at one more. We can look at one more, still in the same magnitude, in the same magnitude. Okay. I have another. In fact, by the way, even there are some numbers, I don't know that I'll get that number. There are some numbers, because here, there are some numbers that you would do, and even they require you to bring, more so when you are dealing with these trigonometry numbers, the numbers you are going to do, whereby time is going to come, whereby you need to apply your knowledge of our formula, whereby you need now to bring in things of our formula for you to be able to get somewhere. For you to be able to get somewhere. So now you need to know that here now, when it comes to questions that when it comes to these questions that involve application, you'll not only need one topic. You may find that you are going even to utilize another particular topic for you to be able to get the proof. Also, when it comes to numbers that concern prove something, you'll find that the knowledge you need is not only for one topic, but you need quite a number of topics for you to be able to get there. So that one you always need to keep it at in your head that probably here I'll need quite a number of topics to apply. I don't know whether I'll be able to get a number of that nature, but let me see whether I can get for you at least one number whereby the application will require more than one. So let me say we are going to go with this. Okay, just give me a minute. I get that number that where we need now to apply more than one rule, whereby we shall bring in the idea. I don't know if I have it here with me, but I would have loved that we interface go with that particular number. Okay. 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 So we are going to say our y is equal to x. Our y is equal x sine of x plus cos of x divided by x cos of x minus the sine of x. Yes, and we are going to show that I don't know whether because it will take us some time. It's going to take us some time, but anyway, we are going to continue. Show that our dy dx is equal to x squared out of x squared plus 1 sec squared into x plus cot inverse of x. Yeah. So something like that. Now, when you look at this number, you are going to notice that at one point, you are going to bring in quite a lot of knowledge. Not only knowledge of differentiation, but you are going to bring in your knowledge of trigonometry at one point. So that means that's why now for some of these topics that involve you proving something, showing something, you'll find that you need to be well conversant with all the topics. That's why it is always important for you to be well conversant with the integration, trigonometry, and differentiation. Those topics will go hand in hand. So when you look at this, it is okay. We can still apply the same thing. So if I want here, I can apply the same. So it is up to you to use which approach you really want. But like I've said, I've always wanted to use only natural log for such a number. So I'm going to first come and I say, I can introduce natural log this side, introduce your natural log this side as well. X sine of x plus the cos of x out of our x cos of x minus sine of x. But like I've said, it will depend on which approach makes sense for you or which one is easier. But here you can as well use your quotient rule. So I can continue and I say this is natural log of ln of y into the natural log of x sine of x plus cos of x minus the natural log of x cos of x minus the sine of x. Now when it reaches here, you do your differentiation. But I want you now to take note of what we have here. Now, what we have here, take note that we are going to differentiate this. But when you look at x sine x, when I'm differentiating dx of x sine of x, you notice that here, this is a product where I have u, I have v. So can members first differentiate for me this alone? First differentiate for me x sine x. What do you get? Such that we don't go back that side. Another one can, even others, let us also differentiate x cos x. What do you get? Remember here now, you use your u and v. You use your product rule. X is a variable that changes, sine is a variable that changes. So you go back, your v du dx plus your u dv dx. So differentiate and put your answers in the chat for those two. Differentiate and put your answers there. Okay, Lydian has got sine x cos x good. Is everyone getting that? Here she has got x sine x, x cos x. Okay. In case that's not what you are getting, you check out you keep V, differentiate U. Keep U, cash banks. Can you check out? Something is missing on your answer. Something is missing on your answer. Something is missing on your answer. Mhm. Okay. Uh-huh. Okay. Uh-huh. Okay, that is okay. Okay. Uh-huh. The first one now it is okay. What about the second one? Okay, even the second one. So members, in case you are not getting this, then check out. Remember, for this one, your V is sine x. So here you put your sine of x. Here, put your sine of x. V Sorry, V is the sine x. Du dx, your u is x. When you differentiate x, you get 1. Then plus x, when you differentiate V, you get cos of x. Okay, so at this point here, I'm going to just be quoting them. So here, we shall have our 1 out of y with respect to y. I have differentiated ln of y. So y means when you differentiate y, you get 1. Divide by the original thing is equal to, I'm going to differentiate x sine x. Members have obtained sine of x plus x cos of x. Then when you differentiate cos, you end up with a negative sine of x. Everything divided by the original thing, which is x sine x plus cos of x. Then minus this minus. So when members went on and differentiated x cos x, they got that. So it's going to be cos x minus x sine of x. When I differentiate sine x, I end up with my cos of x. So this is going to be my cos of x. Then everything, I'm going to divide it by the original thing, which is x cos of x minus the sine of x. Members, are we on the same page on that step? On that step? Uh-huh. Anyone who's lost at that stage? At that stage? Okay, we'll continue. Okay, let me first speak on. Yes, Rose?
I beg your pardon. From from where that green mark is.
Okay. Have you differentiated? Oh, because that's where, like,
Yeah,
I'm going to, you have differentiated x cos x.
yeah.
So when you differentiate, you get this. I have substituted that. Then when you differentiate sine, you get this. The
Okay.
same thing here. When you differentiate this, you get this. When you differentiate cos, you get this.
Okay.
Have you understood? So I've just substituted.
Then why did you divide?
Divide. Like, remember, whenever you are dealing with a tan, sorry, with the natural log, you always differentiate this first, you get 1. Then after divide by what you have differentiated. That is the rule.
Okay. I've got it.
Okay. Okay. So members, we are going to continue. So you notice that this and this can reduce. So meaning that here I can remain with x cos of x. Then also you notice that this and this can reduce. So when they reduce, you notice that I remain with a negative and a negative. So everything here divided by x sine x plus cos of x. Then I have plus x sine of x out of x cos of x minus sine of x. And everything is 1 out of y dy. But do not forget here, you differentiated with respect to x. Here you differentiated with respect to x. So that is the first step we have to go through. Then from there, we are going to simplify. So you simplify according to your means. So allow me here to first remove the dx. I take it this side such that I have my dy dx. But I'm going to first leave the y this side. Then I'll have x cos of x out of x sine of x plus cos of x plus my x sine of x out of x cos of x minus sine of x. Now get the LCM. Now we are going to simplify what we have on our left. Yes, Dr. Jimmy?
No,
Yes?
it was the same concern with that of Lucy.
Oh, okay. Okay. So what you are going to do, we are going to simplify what we have on the left. So when you look at what I have on my left, you notice that our LCM is going to be x sine x plus cos of x. Then I'll have x cos of x minus sine of x. That's what I have. So what am I going to do? I'm up here in my numerator. I will have my x cos of x. I multiply with x cos of x minus sine of x. Then plus my x sine of x into x sine of x plus cos of x. So you open up your bracket, you'll have x squared cos squared x minus x cos x sine of x. I'm opening the bracket plus x squared sine of squared x. Then plus, you notice x sine x cos of x. Everything divided by x sine of x plus cos of x into x cos of x minus sine of x. Now, when you look very well, you notice that this and this are the same, so they go. When you look up again, you remain with x squared cos squared x plus x squared sine squared x. Everything divided by x sine x plus cos x into x cos x minus sine x. Members, I want you to look up and you tell me, if we simplify the numerator, which answer do you get? If you simplify the numerator, which answer do you get? Which answer do you get? Is everyone seeing the x squared? X squared. Very good. Yes, you notice that you remain with x squared. You remain with x squared. Then everything will be out of x sine x plus the cos of x into, here we shall have x cos of x minus the sine of x. Now, you are going to allow me to also reduce in the denominators. We can as well reduce the denominators if you wish. If you wish, we can reduce the denominators. You can open up the brackets and then you reduce it further. So can you do for me that? You can do for me that. reduce the denominators and you tell me what you get. Mhm. So if you don't want, it is also very okay. But remember, members, we are still continuing. There is 1 out of y, dy, dx. So you are going to allow me to clean this side here. We can even first leave to reduce a bit, no problem. I want to come back here a bit. I want you now to observe that at this point here, I have my dy dx is equal to my x squared divided by, even before we reduce, x sine x plus cos of x into my x cos of x minus sine of x, then times our y. But what is y? Y is x sine x plus cos of x, everything divided by x cos of x minus sine of x. So what are you noticing? That this and this are the same. So that means that your dy dx gives you x squared out of x cos of x minus sine of x, but everything squared. This is 1 and this is the second. So members, are we together up to that point? Before we proceed, how did you get x squared? Now from here, Deborah, you can check out that from this point here, x squared is common. So inside I'll have cos squared x plus sine squared x. Then from your identities, cos squared x plus sine squared x is 1, then times x squared. So you end up with x squared. So that's where it came from. Thank you, Gilbert. Yes, Jimmy?
Master, you had left me behind where you multiplied the denominator, where you multiplied the denominator with the numerator.
Mm.
Master, I'm looking for where the plus came from. I'm not getting
Which
it.
plus?
And you've rubbed it off. It was there where you have just written it. Okay, this one in pink, but the step above it was above it.
What was it about? It was just where the
After
plus.
you had got the LCM.
The plus is here
Okay.
because here between them,
Yes.
remember this will
Mm,
multiply the whole of this. Then
mm,
this one here multiplies the whole of this.
mm.
Hmm.
Okay, that was the plus that was disturbing me.
Oh, okay. Okay. Yes, Ruth?
Teacher, the plus sign is saying, okay,
Hmm.
if you don't differentiate properly, when me I had made that mistake. If you don't differentiate properly,
Hmm.
first of all, if you don't use the product rule well here on the x cos x dx, okay, in the previous slide,
Hmm.
I had gotten cos x plus x sine x. Like when I differentiated cos x, I got a
Hmm.
positive sine x. And so when I come and fill it in here in my
Hmm.
quotient rule before I actually get the LCM, I was
Hmm.
having a negative, not a positive, in between those two.
Oh.
What? Yes. So that's what he was
Eh.
asking. So it all stems from what? How you differentiate your cos x, knowing that cos x is, when differentiated, is negative sine x, not positive.
Oh. Okay.
Yes.
Okay. Okay. Thank you, Ruth. Okay. I think members, are we still together? We have not yet finished this number. Remember, Bettina, we are just showing. Now, because I wanted to show you that there are some numbers you're going to do that will require you to bring in other identities. Now, when you look at this number here, they want us to show that you get this when you differentiate. Now here, this is where you're going to bring in your R transformations. You looked at R at one point. I remember, maybe. So you remember from your R, like when you look at this here, you can bring in your idea of R. Remember, like in your R, you say that if I have R cos, now here, since we're in X, I can say X plus alpha. What do you get? When you expand this, you remember you'll have your R. This is going to be cos of X. I don't know that we are still on the same page with this. I want to bring in R. Yes, Jimmy?
Master, since I had lagged behind, so this one where you got dy dx is equal to x squared. Okay, this is step above what you're writing now. The second step above. I'm not getting it where.
Now, this one alone, this one is what you get when you simplify the whole of this. Then there was the y this side. So you multiply it this side. So what we have this side is this y here we had.
Okay, I've seen it.
Okay. So here we shall say of cos of alpha minus our r. This is going to be sine x, sine of alpha. Now, remember, what do we have? We have this. I want you to look inside. So inside, we have x cos of x minus the sine of x. So what are we going to do? We are going to relate. What are we going to relate? I will relate this to what I have here. I relate this to what I have this side. Hope you remember how you were using your thing. So it means that when I relate, I'll have something like this, that r cos of x cos of alpha is the same as x cos of x. So at this point, these two coses cancel, so I remain with r cos of alpha equals to x. Then when I look at negative sine x and the other one, I'll notice that I have negative of r sine of x sine of alpha equals to negative sine of x. So the negative and the negative cancel, the sine and the sine cancel. So that means I remain with r sine of alpha equals to 1. Can you first tell me whether we are together up to that point? First, let me know whether we are still together. Are we on the same page up to that point? You need to remember your R. We are using R formula. So you need to remember your R. Okay, someone is saying, you know. Let me repeat code a bit and we see. We are saying that when you look at this here, and you look at where you are heading, you look at this vx squared and the rest, it means that we must eliminate x cos x minus sine x. But for us to eliminate this x cos x, we can utilize our knowledge of the R formula. And from our R, if we begin with a cos, it means that I can use cos. So you remember that cos of x, here we can use the plus alpha. When you expand, this is the same as r cos x cos of alpha minus r sine of x sine of alpha. Now at this stage, you equate x cos x and this. So this, it means that I'm going to equate the corresponding coefficients because I want to decompose. I want to decompose this cos into this format. I'm trying to decompose. So what shall we have? We shall come and say that our r cos of x cos of alpha is equal to x cos of x. Now the cos and the cos can cancel. So you get your r cos of alpha is equal to x. Similarly, you equate this. So you say negative r sine of x sine of alpha is equal to, you equate negative sine x. you say this is equal to negative sine x. So that means you get r sine of alpha equals to 1. Now, the moment you reach at this stage, then you apply your rules. What are you looking for? You are looking for the angle. You are also looking for what r is. So you remember from your knowledge of trigonometry, of saying sine squared x plus r sine cos squared x is equal to 1. So I can come here and I say r cos of alpha squared plus my r of sine of alpha squared. I must end up with a 1. So here it means I'll have r squared into cos squared alpha plus the sine squared of alpha. The moment I add, I must get 1. But this side, there is something I'm going to add. But let me first remove this step here, such that now it becomes easy. Because this side, I don't know whether members are saying I'll have to add an x squared. I don't know. Is it clear, or I repeat call from there? Because I want you to remember that when you have r cos of alpha, when you square this side and I square this side, it means I'll have r cos squared alpha is equal to x squared. Even this r is squared. Still, when I do for sine, I'll have r squared sine squared alpha is also equal to 1 squared. So I'll have r squared sine squared of alpha is equal to 1. Now, these two here, when you look at this and this, when you add them, you get this statement I was writing here. But what do you notice? R squared is common. So when I factor it out, I will remain with my r squared into my cos squared alpha plus sine squared alpha equals to 1 plus x squared. So here, this one inside it gives 0, 1. So r squared will equal to 1 plus x squared. So that is the first thing. So in case I want to get r, I'll get the root. My r will be the root, such that I come back here. So here I will say my r is going to be 1 plus x squared, but everything into a root. Are we still together up to that point? First, let me know. Have you got how we have obtained r? Okay, r is okay. R is okay. Now, after getting r, we can now obtain our angle. We can obtain, because remember, when we are decomposing here, you need your r, you need your alpha. Now, I want to get this alpha here. How am I going to get alpha? Is the angle. So I'm going to come here and I say, my r cos of alpha is equal to x. My r sine of alpha equals to 1. Now, in order for us to get the angle, that's where we divide. I divide the two. So that means I'm going to come here. Now, you're going to pay more attention here a bit, that I have my r sine of alpha is equal to 1 and my r cos of alpha is equal to x. So when I divide, I have r sine of alpha equals to 1 divided by r cos of alpha divided by x. So the r will cancel, so I remain with sine alpha out of cos alpha is equal to 1 out of x. Now, at this point here, you are going to ask yourself, sine divided by cos, what do you get? I end up with my tan of alpha equals to 1 out of x. So, at this point, what do you notice? I want you have to have that mathematical eye, that our answer has something like cot inverse of x. You ask yourself, if I'm to get here a cot, how am I going to get it? That for me to get a cot, it means that I'll have 1 out of tan of alpha, which will be now, here, I don't know whether members are saying this is x. When you take the reverse, alternatively, someone could just say that r cos of alpha is equal to x divided by r sine of alpha divided by 1. Such that here you get up cos out of sine gives you a cot of alpha equals to x. So your alpha will be cot inverse of x. Let me first answer some questions from there, because now we are applying and we look a bit ahead. Yes, Dorcas?
Good morning, teacher.
Morning.
Could you please go back to the other screen?
Yes.
Yes, teacher. I have understood everything, but I'm requesting you to please go in this step where I will introduce the square.
The square? Where?
Here, yes.
Here.
Here. Yes.
Oh, now this one comes from this identity that sine squared x plus cos squared of x is equal to 1. Now, if I want to eliminate cos alpha, I want to eliminate sine alpha. So I can square both sides, that cos of alpha equals to x. So I square this side, I square this side. So when I square, I get r squared cos squared alpha equals to x squared. When I come this side, r sine squared, and I square, I will get r squared sine squared alpha equals to 1. Is that fine?
Yes.
Now, when you add the 2, you get your r squared cos squared alpha plus r squared sine squared alpha equals to 1 plus x squared. Now, r and r are common. You pull them out. So once you pull them, you get cos squared alpha plus sine squared alpha. But cos squared alpha plus sine squared theta is 1.
Yes.
So that's where we are getting that.
Teacher, when I not considering this square in the dy dx denominator.
In there?
Like in this expression of dy dx here.
Now this, we are still simplifying. Now this squared came from here. Remember, when we simplified when we simplified this side here, this is what we got. But remember, when we are differentiating, there was this y here. So you have to bring the y and multiply it this side. So when we brought it and multiplied, this is the y. But this and this could cancel. But this x cos x minus sin x, x cos x, these two are the same. So you multiply them, which is the squared here.
Okay, teacher. So this square for it is still existent. We have not yet touched it with other.
I've not yet touched this squared here. Because I'm still expressing it in this form, I'm still looking for this. Okay.
Thank you.
Okay, so I'm going to come back here. I'm coming back here. So I'm going to say that we have our r cos of x plus the alpha. Now, we got our r from here as root of 1 plus x squared. So our r is going to be 1 plus x squared. Then cos of x plus our alpha, which we have obtained as cot inverse of x. Now, when we go back, I'm going to go back in my dy dx. So we had our dy dx equaling to, our dy dx was equaling to x squared out of this thing squared. So I'm going to say this thing x squared divided by, remember down, we had our x cos of x minus sine of x squared. But the whole of this inside the bracket, we have decomposed it to this. So now I'll come and I say our dy dx will equal to x squared divided by, now the whole of this squared. So we are going to have 1 plus x squared cos of x plus cot inverse of x. I want to remember everything is squared. You square everything. So when I square everything, I'll get x squared out of, I square this, 1 plus x squared, everything squared. Then I also square that one. That one becomes x cos squared x plus cot inverse of x, like that. Now you notice from here that these two and this one are going to cancel. So you are going to remain with x squared out of 1 plus x squared. Then you ask yourself, members, what is 1 out of cos squared into x plus cot inverse of x? What is 1 out of cos squared giving us? Sec squared, eh? So that one will give you a sec. So it will give you a sec squared of our x plus the cot inverse of x. So that's how you prove such. So you notice that you need now to have that mathematical eye where you are heading such that you can be able to get there. Okay, but you have noticed that for whatever thing you study, you may find yourself applying it somewhere in front. That's why now you find that trigonometry will come after, trigonometry comes first, then after you have to bring in some bit of differentiation. So that's where, because now here you need to learn how to decompose things. Yeah. Have we picked something? How did the x squared disappear? Which x squared? The x squared is still here. We have maintained it still here. Maybe you are meaning this squared here. This squared here, remember when you bring this squared, the square affects this and affects this. That's how we bring it inside. Keep saying. So how did you introduce the root? The root came from this side. Remember, you got your r as root of 1 plus x squared. So when I substitute r, I put it the way I had obtained it. So that's where the r came from, Jedis. R, which r? Jimmy, I'm not getting what you are saying about the r. Yes, Jimmy.
Master, I don't know whether you can go back to the previous slide.
Mm-hmm.
There where we there. Here where we have dy dx is equal to x squared, then out of x cos x minus sin x squared all squared. Now, Master, how did we get this r cos x cos?
Now, this one is an identity we have picked from the R formula. You remember your R formula from your trigonometry? That if you are so from trigonometry, so you have to go back to your trigonometry. That's where I'm picking this. And when you look at this, in case I want to decompose it into one, I can use that knowledge of trigonometry. So I don't know, Jimmy, you need to go back to your trigonometry where you covered how to solve those trigonometric equations. Remember, from your trigonometry, I know some of you are just used to this, that when I had cos x minus 4 sine x and they tell me to use R formula to solve, that's how you solve. But now for this case, instead of giving here 2, they gave you an x. Instead of giving here 4, they gave you 1. So you have to apply the knowledge. I don't know, Jimmy, you're getting the idea, where the idea is coming from.
Yeah, I'm getting it, Master. I'll review it.
So you go back and first review that trigonometry of our formula. Yes, Abel.
Excuse me, teacher.
Mm.
We're here on the second last step before the answer.
Mm.
After squaring the denominator, how have we got the sec?
Sec, like here is that you have 1 out of cos squared x plus cot inverse. But you know that 1 out of cos is the same as sec.
Yes, I've seen.
Okay.
Thank you.
Okay. So, members, are we good to continue? Is that okay to everyone? Go to go. Okay. People are saying, yeah, we can continue. Okay, so let's continue. Yes, but please do make sure that for whatever thing you study, you know that at one point you are going to use it. Okay? Now we are going to also do something from this part. Now, when we are modeling, when we are doing these models, many of these things you see, they are real life. They are real life. When you look at this, I'm going to stop sharing and I first show you a bit of a curve. So when you look at this, I want to plot this. H is equal to 2000 into, I want to plot this. I'm going to plot this and you have a look how that curve looks like. Let me see. So allow me to, so here I'm going to use Y because the software knows Y. So when you look at this plot, what is happening? I wanted to, okay, let me first remove. I wanted to show you how it looks like that Y is equal to 2000. Oh, okay. Log E. This was x plus 1. I don't know, I might. Okay, let me first delete. I wanted to show you how that curve looks like, but I don't know. Oh, okay. I get this scale is very big. So the scale is very big. So I'm going to increase the scale. I'm going to increase the scale and I see how it comes about, whether I will be able to get it. I wanted to, okay. Let me see whether I can be able to get what I want. Okay. Hope you are seeing what I wanted. Let me increase it a bit. Now, when you look at the curve we are going to come out with, it looks like that. That is the kind of curve. It will look like that. But what did I want to show you? I wanted to show you that when a plane is going up, when you have a plane and a plane is going up there, like when it has started its journey is curved, like it goes like that, like you see it goes like that, then it goes up like that, and then after it reaches a point whereby it is almost like traveling at the same line, or like on a straight line. But it first goes like that, those who have been there, and then after it goes. Now, those kind of curves that model are these natural log. But here I told that lean is the same as the natural log. So this is how that curve looks like. When you try to plot, you'll find your curve going like that. So this one, like, it shows us how does the plane move. So the same thing can happen when you are playing soccer and you kick a ball. You look at the ball going somewhere like that. So those kind of models, we can use these natural logarithms to come up with such. So that is this kind of scenario. That's what it's trying to show you what happens. What happens. So allow me to go back. Yeah. Now, they're asking us that find the rate of the climb at t equals to 3 minutes. May I first ask you, they have given you your function, which is h is equal to 2000 natural log of t plus 1. Can we first find out the derivative of this? Whenever they ask you the rate of climb, at what rate? Now here the rate is like the speed indirectly. That's what they're asking. At what speed is this plane going up? That's what they are asking. So can we first find out that kind of speed? And you know that speed is given by distance out of time. So here indirectly, you are finding out what is the dh dt. So can we first find out and you tell me what you are coming up with? A, DS is asking, is there any way? Now, our formula will always come whenever you find things in this nature. In this nature, whenever you find, let me say this is A cos of something minus B sine of something. As long as the angles here are the same, as long as you check that the angles here are the same, even if it is cos x plus sine x, as long as you check the angles are the same, here, this one doesn't matter, whatever variables you have. But as long as you have a mixture of cos and sine, you have either an addition or subtraction of a cos and a sine, and the angles are the same. Angles being the same, even if this is 2x, this is 2x, this is 5x, and this is 5x, our formula can always come in. Hope JDS, that is okay. Okay, so can we first try this on our own? Yes. So okay, 500. Someone to take us through? Someone to take us through? Who wants to take us through this? Okay. Yes, Jimmy?
As I want to try that one.
Okay.
Okay, we are getting dh dt,
Okay.
and you've written h. No
Okay.
x.
Okay. Okay. So our h is equal to 2000 natural log of t plus 1. Okay. So you're getting the h, the
T.
mm-hmm.
We shall differentiate this ln of t plus 1, which is 1
Mm-hmm.
of t plus 1.
Mm.
Now, dh dt at t is equal to 3, is out
Mm.
of 3,
Okay. T is equal to 3. Yeah?
3
Okay.
is t 2000 out of 3 plus 1.
Mm.
It is 2000 out of 4. And then it is 500 feet.
500. Uh-huh. Now, what are the units? What is the h, the t?
It is in feet. No, sorry. That is in feet per minute.
Feet
500 per minute.
per minute. So remember, members always define it very well that the h is given in feet. The t is given in minutes. So that is feet per minute. And therefore you make your conclusion basing on that. So in other words, what you are finding here is what you call the vertical velocity on how planes move. And that is how, best by the way they move, most of them at around that kind of speed, 500 feet per minute. And when they are measuring that distance when it is going up, they mainly use feet. They mainly use feet. So those who are going to go into that field, you'll be able to see that. Yes, Baswali?
Teacher, on this, can't we differentiate the 2000
Where?
up
Remember,
there?
2000 is a constant. is a constant. So for it is not affected at all. Or you go back to the first principles we looked at when we are differentiating this. The first principles we looked at. You use your chain rule. You let your u equals to ln. You can say let your u equals to t plus 1. And then you say yeah, h is equal to 2000 ln of u. This is a constant. It's not affected. Like have differentiating 2x. You don't differentiate 2, you only differentiate the x.
Oh, thank you, teacher.
Okay. Okay. Can we now also try out this? Mm. I'm interested in part A first. I'm seeing some answers coming in. People have gone to part B, user without part A. Okay, maybe let me start from there. And then, now when you look here, they told us that during a chemical process, the mass of the substance grows exponentially according to that. Find the time taken for the substance to increase 3 times its initial mass. Now, the first thing you always have to do, you ask yourself, what do they mean by what was the initial mass? Now, you think quickly that initial mass, T stands for the time. Initial mass means that what point is that? So that is the point initially when you are starting. So what is the value of t at that point, members? What is the value of t? The time. Thank you, Ms. Meta. Time is 0. So that means that you will say at t equals to 0. That is what you call the initial time. So that's when you find the initial mass. So I'll say my m is equal to 20 exponential of 0, 0 to t. So when at t equals to 0, that's when you obtain the initial mass. So I will say that m naught, which I'm using to represent the initial mass, will be 20e 0.02 times the 0. So I end up with 20e power 0, which is 20. And that is m naught. So that means that the initial mass was 20. Now, after getting that initial mass, the next part you have to find is, they have asked you, at what time will it be when this mass has increased to 3 times? So now you say, what is that? So the increase, I will say, increase of 3 times. So members, what mass shall we have at that point? If the initial mass is 20, when it increases by 3 times, which mass shall we have? Very good, very good. It will be 60. Thank you, Ayob. Thank you, Jennifer. So that means that our mass we are going to operate on is going to be 3 m naught. And this is the same as 3 times our m naught, which is 20, and this will give us the 60. Now they want us to find the time. So finding the time, meaning that now we are going to solve this kind of equation we have. So what am I going to do? I'm going to, oh, sorry, I didn't leave space. Okay. I'm going to come here and I solve. So you have your m equaling to 20 e 0.02 t. Where there is m, I'm going to put 60. So I will say 60 equals to 20 e 0.02 t. Now you can solve by saying 60 divided by 20 is equal to 20 out of 20 e of 0.02 t. So what is 60 divided by 20? You get your answer as 3 is equal to e 0.02 t. Now, remember you are looking for t. Now, at this point is where you bring in now your natural log to remove this e. So we shall introduce natural log on both ends, natural log on both sides. So at this point, I'll have my natural log of 3 is equal to 0.02t natural log of e. But remember, we said natural log of e is the same as having log e, which is a 1. So at this point, it means that I'll have my natural log of 3 equals to 0.02t divided by 0.02 divided by 0.02. So that means that your t is equal to 0.01 out of 0.02 is the same as the 50 natural log of 3. And now this is your time. But since they give us our time in hours, it means that your t is the same as 50 natural log of 3 hours, which now you can write in decimal points as this is what 54 point, what is 50? 50 natural log of 3, 54.93 hours. Yeah, so that is how you work it out for part A. Members, are we on the same page? No, we put the hours. Yes, Bettina.
Good morning, sir.
Morning.
Yeah, so to make it out there from introducing the natural log, some padding.
I'm not getting your saying?
After introducing the natural log,
Mm.
I request for pardon from there.
Natural log, where? Natural log.
I had 3 is equal to e by
Here.
0.
Here.
Yeah, there.
Are you seeing this?
Yes, teacher.
Is what we drop. Like that is the same as having log of e of power 0.02t. So in logarithm, this power can be dropped here and you get 0.02t log of that one. But this log of e is the natural log we have. So log of e is a 1. So you remain with 0.02t times 1, which is 0.02t.
I've got it.
Okay. The rest, are we fine? Is everyone okay now? You do for me part B. Let's be doing part B. Yes, Linda?
So I'm lost from that part where we divided by 0.02. And I'm
Hey,
saying that, yeah,
like
and I'm
we
saying that,
have, okay. Linda, can you first do this on your calculator? 1 divided by 0.02. What do you get?
by 0.02,
Hmm.
I get 50.
50. Now,
Yeah.
0.02 in fractions, I can write it as 1 out of 50. Are you seeing?
Yeah.
So that's where it is coming from. So instead of saying ln 3 divide by 1 out of 50, which gives us ln 3 times 50 out of 1, 50 ln of 3.
Okay, thank you, sir.
Okay. 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 Okay, good. Okay, now we are trying part B. Let's do part B and see what we come up with. So when you get the answer, feel free to share with us in the chat. Whenever they ask the rate of change of m, the rate means a ratio with respect to time. Mhm. Okay, 2.9. That's what people are getting, 2.9. I'm still waiting for other answers. Hey. Okay, 2.9. Let me be creating space here. Okay, as I go back, are we getting 2.9? Esther is getting 2. Esther, can you raise up your hand? Esther, if you can unmute. Esther, unmute.
Yes, teacher.
Yes, Esther, can you take us through? as others are finalizing?
Okay, I'm not really sure, but okay.
It is okay. It is well.
Okay, what I did,
Mm.
M is equal to 20 E 0.02T. So what I did is I brought the in on both sides. So it became in M is equal to in into in 20 E exponential 0.0. So in M is equal to, I expanded this other side of the equation and it became in 20 plus in E 0.02T. Yeah. Then it became in M is equal to in 20. Then this side did I say expanded? I don't know, but it became plus 0.02T in E. Yeah. So I know in E is 1. So at the end of the day, I got in M is equal to in 20 plus 0.02T. So now I'm going to start differentiating. My in M, I got 1 out of M dm. And I think in 20 is 0, right?
You're very correct. I agree.
Oh, okay. 0 plus, now when I differentiate 0.02T, I get 0.02 dt. So I'm going to divide dt on both sides. And I'm going to get 1 out of m dm. So dm dt I've divided is equal to 0.02. Then I multiply m on both sides. Get dm dt is equal to 0.02 m. But they told us m is 100. So my dm dt is 0.02 times 100. So my dm dt is going to be 2 feet per hour.
2, what are the units?
2 feet per hour.
We go back, read through.
I'm so sorry. 2 kilograms per hour.
2
Yeah.
kilograms per hour. Thank you so
Yeah.
much, Esther.
Welcome.
Okay, yes. Now, the accurate answer is 2. The reason why I chose Esther, because I saw her, she had the accurate answer. So I was curious to find out how she got it. Now, the rest, we could as well get the accurate answer, but our approach could be a bit different from Esther. But for you, I know, the other members, I know, allow me to start from where Esther stopped here. I know when you differentiate your thing, here for you are getting 0.02 times the 20 e of 0.02t, and you ended up with the, what did you end up with? 0.02 times 20, 0.02 times 20, you ended up with 0.4. 0.4 E of 0.02t. Now, if you wanted, if you had, because they told you your M is equal to 20. So if you are to get 20 at this point, this is where I told you you needed to bring in the mathematical eye and then ask yourself, how can I be able to create, to create this M? So someone here could come and someone could come here from this point and say, my M is equal to 20. e of 0.02t. But I will have this one. Can't I divide this side by 20? I divide this side by 20 and I get m out of 20 equals to e 0.02t. Such that where there is this, I put this. So you end up with your m out of the t is equal to 0.4 times m out of 20. And therefore 0.4 out of 20, 0.4 divided by 20, you'll end up with your 0.02 of m. Someone could do it in that particular way, and then you end up with that answer. But this was very good. Thank you. Thank you, who? Thank you, Esther. Another person, even if you had reached here and you said, but what is my M? My M is 100 out of 20. So this is 5. So someone could come and say, where there is this one, I'm going to just put 5. That one could as well work out. Members, are we together on that point? And do not forget, some of you have not used the natural log to differentiate. I know for you, you can differentiate directly. It is as well very, very fine. Okay. Yes, Moses. Moses, unmute.
Excuse me, sir.
Yes.
Teacher, me when I replaced m equals to 100, I was stuck from this point. I don't know if it's correct. I got lean 5 out of 0.02.
Where? At what point
Right.
did you substitute?
I from the first point, from this m equals to 100.
Here.
Yes, I replaced by 100.
Uh-huh.
But I mean, okay. So when I replaced by 100, I divided both sides by 20.
So you got 5.
I got lean 5.
Where did you get lean 5? Because if
Lean
you
5,
divide by
when you
20,
divide 20,
you get
20 by
5
100. Yes.
is 0.025t.
So this side it was lean 5 out of 0.02 is equal to 0.02t out of 0.2. So I was stuck from that point.
What were you trying to find time or?
Yeah, I was trying to find m using a t.
Oh, because had you finished to get your DMDT?
No.
Because you cannot substitute before you find out the change.
Okay.
So first find a change before you substitute.
Okay, teacher.
Okay. Members, are we good to continue? Jonams, what are you getting? Jonams is saying is getting. Jonams, what did you get? Because
Teacher,
when you... Yes, Jonams?
teacher, for me, I got 2.9 something.
How did you differentiate?
Like, I said m is equal to 20e power 0.2t. Then I differentiated this. Remember 0.02 for it to I bracket it out. Then I differentiated the e power 0.2t. So when I differentiated it, I got 20 times 0.2. Then e power 0.2t.
This is okay.
Then when I substituted in the t up there.
Oh, remember you didn't have a t. Jonah, they didn't give you a t. They gave you an m.
Oh,
They gave you an m, not a t.
okay, sir. Thank you, sir.
Okay. Okay. Yes, Bettina?
And so my inquiry is on how to differentiate lean 20 to come up with a zero.
Oh, Bettina, first differentiate. You first do for me this one. Differentiate for me. What do you have for the y, the x?
That is equal to 2x
2x. What do you get when you differentiate this?
a zero.
A 0. Why?
I don't know, it's just like that.
Okay, but there is an x to power 0, right?
Yeah?
Here, when there is a constant, there is an hidden x to power 0 because any number to power 0 is 1.
Yes.
Are you seeing? So when you multiply 2 times 0, you get 0. That's why it becomes 0.
Yes?
Have you got it?
Then does it still apply when we are having lean
Ah,
20?
Even if I have ln of 5, let me start from 5. If there is no variable that changes like x, here it means that there is an x to power what?
Zero.
0. So the moment you drop this 0 here, you get 0 times ln of this, and 0 times anything, it is a 0.
Yes, teacher, I've got it.
Okay. Okay. Now, members, uh, why don't I give you some numbers you're going to try out? Take a screenshot of that. So here, I don't know that you are not seeing that now. We can have two things combined. You can have solving equations, combined with differential equations. Even you saw how we brought in the trigonometry bit of it. Okay, have we taken a screenshot? And here, this one also wants you to show. So you are going to be showing. Okay, let me give you another one. I thought I had another one. I have another one. All these ones are just for proving. You do. I don't know that I need to give you the answer. Should I give you the answers? I don't know what members think. Should I give the answers? If Okay, I think members want me to give the answers. Okay, let me give the answers. So I'm going to allow me to, for this particular one, for here, the number of mice at the start of the investigation, is it the one? Where? Here, the number of the mice at the start is going to be, find out at the start of the investigation. Here, I expect you to have your answers 100. The number of months here, I expect you to get around 11 months. Then this one is for proving. So for it, it is until when it comes out to the way it is that you know that you are right. Okay. I'm going to go back to the first one I gave you. Then determine the value of t when the road reaches 260. For that one, I expect you to have an answer of around 45.0043, something like that. No, wait. That one is for this second part. Sorry. This one is for this part here. Then for this one, for the value of t here, it should be 6.93. Or that is what? 10 ln of 0.5. But to be Okay, this is 0. In fact, even here, because there is a negative here, which becomes 0.5 power negative 1, which gives you a 2. Okay, let me say 10 ln of 2 here, or here, this one should be 10 ln of 2. Either you get this or you get this. For this part A, then for this part B, 45.0043. Then this one, you prove that it comes out. Any questions? Those are the two I want to give you, unless, but if you want, I can add you one more for normal differentiation, but applying the rules. Let me so that I can give you one. Okay, let me give you one here just to try. That's your dy, our y is equal to 1 out of x exponential of x cos of x. Yeah, and you're going to try that one and show your answer. Your answer should be which answer should it? Okay, you try that one as well. Try that one and see what you come up with. But your answer will be something like 1 out of x ex cos of x into negative 1 out of x plus tan of x minus 1. Something like that. Okay, members, I think those ones will be enough. Once you get those answers, we shall be very safe. We shall be add more. Show second one. You had promised. Oh, sorry. Sure, I had promised, but my programs didn't allow. My program was very tight. Yeah, but I'm going to work on it. Let me get time and I work on it. Yeah. Okay. So you try those two, and then we shall start from there. So tomorrow, we shall start on another concept of the Maclaurin's theorem. That's what we shall start on tomorrow. And